Now that we've gone over air masses, we can talk a bit about fronts. And you've got 4 different types of fronts. You've got cold fronts, warm fronts. These two you've probably heard about quite a bit if you've watched the Weather Channel at all. You've also got stationary fronts, and those are exactly what they sounded like. Stationary. They're not moving. And you've got occluded fronts, and we'll get into what exactly those are in a little. So stationary fronts, like I said, no movement. It's a boundary between polar and tropical air masses. They're not moving around. They stay exactly where they are. Basically it causes partly cloudy weather, maybe a shower, but not a lot of excitement going on. Once air on either side of the stationary front starts to move, it will form a cold front or a warm front, depending on where the air is moving. So if cold air is moving and replacing warm air, basically it's moving along, forcing warm air that's trying to stay still up over it, it creates this very sharp, relatively tall front called a cold front. You can see this 1 kilometer. Basically what's happening here is you get a very steep slope caused by this friction, and you get storm clouds right over the front, very close proximity to the front, and this warm air is forced up over. This is warm, moist air. This chart details what is happening as this steep, sharp front, this cold front, passes through. That's why these triangles represent that steepness. Rather than being gradual, it's sharp. So you get a blue triangle. So usually what happens when a cold front passes is it starts off warm, there's a drop in temperature as it's going through, and it ends up cold because you're now in the cold air. Again, the pressure falls and is at a minimum during passage. The winds shift 90 degrees as it passes, and you get precipitation a little bit before and a little bit after, but the heaviest precipitation is directly on the front because that front is so sharp and so steep. So again, while they pass, it can pass at different rates. These are relatively set speeds of 15 knots, 25 knots, somewhere in that range. You can see cold front extending through this area on this map. Now, warm fronts tend to be more gradual, and again, that's because warm air is less dense. And that's also that more gradual front shape is why you have circles or half circles for the warm front. So it's warm air replacing cold air. So that dense cold air forces the warm air to ride up over it. So it's very, very gradual over a much broader region. So again, rather than that really sharp front from a cold front, you have a gradual warm front, and that the precipitation happens well in front of the warm front. So the precipitation's happening here while the warm front is all the way back here, around like 600 kilometers difference. And you can see that in this chart. Again, it's cool before, it rises during, and you end up in the warm air. So as it's passing, you end up in the warm air. And it's, again, about a 90-degree shift in winds. You're dealing with, instead of really tall clouds, as is generally associated with the cold front being cumulonimbus clouds, you're dealing with the stratus and cirrus clouds. Basically, the stratus family of clouds. And the precipitation involved, instead of being much stronger, like with a cold front, with a warm front, the precipitation is much weaker and happens over a much broader area. So because a warm front moves much more slowly than a cold front does, eventually the cold front catches up to the warm front and starts going underneath it, forcing it aloft. And when you've got a merging of these two fronts, you get what's called an occluded front. And it has features of both types of fronts all at once. And there are 2 types of occlusions: cold occlusions and warm occlusion. So cold occlusions, again, this is when the cold front overtakes the warm front. The warm air remains but is completely above the cold air. So basically it's forcing all that warm air up. So you have very cold and cold air on the bottom, and aloft is warm air. And the coldest air is behind the cold front. So again, in this area. And you can see how this interacts. So in A here, you can see when they're separate, the cold front and warm front are separate, and you've got warm air on the ground. But as you get into the occlusion, that warm air is forced aloft. This is the most common type of occluded. In some parts of the world, you can have what's called a warm occlusion when the entire frontal system is moving into very cold air. In the Pacific Northwest, this can happen. Basically, you've got maritime fronts moving into continental polar air. So very cold, very dense, and both ride up over the top. So the warm air is aloft, the cool air from the front, basically both fronts are moving up into the air, riding up over the actual air that's normally in that area. And again, here's a chart describing how the different occluded fronts work. So in most cases, they're very similar. Before passage, they're dealing with cirrus clouds, the warm front clouds, the stratus clouds. During passage, you're getting the clouds from the cold front, the nimbostratus, and cumulonimbus. So that's a combination of both fronts. And then after, you're again dealing with the clouds after associated with a cold front and with a warm front, and it ends up clearing. Now, the main difference between them is how it impacts temperature. So with a cold type, it ends up colder after the passage because the coldest air is moving into the area. With a warm type, the coldest air is already there. So through a little bit of mixing and providing energy, it ends up bringing in slightly milder conditions.